Earlier, I went on about the theory of everything having two axioms. One is that everything exists, and the other is that there exists a thing. Now, and there was a third axiom that said there exists. Well, it didn't say there exists, it actually says everything is in everything. So those are the three axioms I have now. And what I'm trying to demonstrate to you now is that there are any number of things. Let's consider that a thing is a person. Okay, well, now I know. Now, there are other people too, right? I exist. That everything exists, right? There are other people. So let's say I know 10 people. Okay, so I know these 10 people, and like, what do you need to have a number system? Well, you need to count them somehow. So like right away, I can say that I can count like 11 people now, me and 10 other people. But then like you want to start asking yourselves more difficult questions like, what's the difference between these people? So we can say, well, they're just geopositionally located in different spaces than you might find them otherwise. And that's how we can say they're different people. So my 10 things are different according to this analogy, which you may accept that there exist things as part of the axiom. If we can just please agree that everything exists and there exist things and everything is in everything. Now, go ahead and say there are multiple types of infinity, right? You know, you can have countable number of infinity, like natural numbers. There's an uncountable number of infinity, like real numbers. And in set theoretic notation, we discuss such things as transfinite double induction. So there are actually plenty and quite a few different characterizations we can make to describe numbers. But all I'm trying to do is prove that these unnatural numbers, which are just, it's not the natural numbers because it doesn't include the number one, exists and it's countable. Well, okay, let's say we have one thing, O dot. Special name I made up for an object, O dot. You know, just a circle with a dot in the middle of it. You can just call it O for short. O is an object, adequate enough. Then we might say that a array containing one element where the element in the array has the value 1 is O. It's an object. That's a thing. Okay. Well, now let's have a collection of objects. Well, I have defined one object, that is the array with one element that has that one element's value being 1 is O. So I'll put O in that collection. And that's part of everything. And well, that's a thing too. It's actually a collection of objects. So it's not exactly an object. It's slightly different. It's a different thing. In an analogy, in a mathematical way, we can say they're not equal, so they're different. They have one characteristic that's different. I'll tell you what it is. One is a set of objects, and the other is an array of numbers. No further explanation is required. They are different. So there are two things now. Okay, great. So let's say there's 10 things, and well, let's say I need to find the third thing, right? The third thing we're trying to identify. Well, that is the first object and the second object. You see how we're counting things now, becoming countable somehow, right? We have the first two, and well, let's say one way of just saying we can make new objects is by defining an operator on the objects. A brief refresher on operators is that An operator may accept arguments and then produce one output, like addition. 1 plus 5 is 6. It accepts the number 1, it accepts the number 5, and it produces the output 6. So addition is an operator. In the same way, we can say, let the relation that we want to be defined as an operator for objects be like object 1 plus, in a special way, object 2 is object 3. Well, let's go ahead and just say object 3 is a sequence of the second object, O2. So it's a sequence of a collection of an array of one element having the value of that element being 1. That's our third object. We now have 3. By induction, then, I may say, I may index the number of parentheses, in other words, the depth of the sequence of the object arrays, increase to infinity. Because for every number n I give, I can find that there is an n plus 1 object. And this is the first theorem of the theory of everything. Thank you.